In this exit slip, I'm assessing students' ability to do the work to find the quadratic equation for the quadratic function with the given information and to be able to graph it. I won't graph it during this demonstration because the graph's small on this screen, but I will show the work behind it and what I expect students to be able to do. So the x-intercepts were at x equals 2 and x equals -1, so students knew how to write, most of the students knew that we were using y equals a times x minus p times x minus q throughout the lesson. And so most students knew to write the factors of x minus 2 and x plus 1. However, some students just left a as an understood 1, and in this specific example, you can't just say that a is positive because they didn't tell you if it was going upward, or a is negative because they didn't tell you it was going downward. So you have to use another point out of the table. We're not going to use the given x-intercept, so I'm not going to use x equals 2 or x equals -1. So I'm going to choose one more point to use for my x and y values to substitute in to see what the a value is to solve for a. So if we make those substitutions, that would be the y value is 8. So you're going to have 8 equals a, I don't know, and x I'm going to use 0 for the 0.08, minus 2, and then 0 again for the x, plus 1. So you have 8 equals -2 times 1 is -2, so -2a. Divide by -2, so a is equal to -4. So then if I go ahead and write, that's the specific equation for this quadratic function, and most of the students did not get that. And then once you use that specific equation, now I ask them, well, the vertex of the parabola is not listed in the t-table, what is the vertex? And they can just use their prior knowledge from the lesson that we used to find the vertex. So we know that the vertex is directly between the two x-intercepts. So if the x-intercepts are at 2 and -1, if you add those together, 2 plus -1, and divide by 2, you get 1/2 for the x-coordinate of the vertex. And then you have to substitute back into the given equation, the one that we found already, to find the y value for the vertex. So the y value for the vertex would be, if we substitute 1/2 in for x, we would get -4 times 1/2 minus 2 times 1/2 plus 1. And so that gives you -4 times -1.5, or -3/2, times +3/2 would be 1.5, and that's going to be -4 times -9/4, and then those 4's divide out and you're just left with +9. So the vertex is at the coordinates 1/2, +9.